Thank you everyone for joining us in this last meeting of the series. The idea is to talk about bio-based technologies, and before we proceed, just a small overview of the project for those that are not familiar with it. BBioNets is a thematic network funded by the European Union and has two main objectives. To enhance the adoption of bio-based technologies and that means practices or technologies that use not food feedstock circularity principles or both to deliver diverse products, so that primary producers can manage and process their biomass. And the second objective is to promote the work carried out by operational groups. How we are trying to achieve this? We have two main approaches, locally and European-wide. At regional level, we created local networks, bringing together primary producers, associations, advisors, experts at regional level, in order to create the seed so that we can spread the information about bio-based technologies in each region. You see the 6 regions targeted from the project in the map below. In each region, we started from analyzing the potential of using biomass, and through the analysis and with the support of the local actors for the agricultural networks, we concluded to the most suited technologies in each region, what we call the best BBTs. And when we completed this analysis, we entered the phase of knowledge transfer, informing the local actors about our findings, about new solutions, innovations, etc. Then, in parallel, at the European level, we brought together primary producers and experts from different regions. The first round had the regional character, regional orientation, meaning that we tried to bring together actors from similar agricultural and geographical and climatic regions, while the second round has more focusing on topics of common interest. Our analysis revealed 6 key areas, and we try to set up a meeting for each one. This meeting is focusing on the Green Biorefineries, is the last of the series. In short, the agenda. We have 3 speakers today with us. James Gaffey from Münster Technological University, Magdalena Broseka from the Institute of Soil Science and Plant Cultivation in Poland, and Andrzej Frik, if I pronounce it correctly, from Slovakia. Then, after these 15 minutes presentations, we'll have the opportunity for more discussion with the speakers. If anyone from the audience wants to ask a question, can just switch on the mic or post it in the chat. And my colleague Malgorzata will be the moderator. So for me, this is very short for now. If there is no other question, we can proceed with James.
Thanks, James. I'll just share slides. Thank you. Morning, everyone. So my name is James Gaffey from Ulster Technological University. I'm going to talk about the development of rural green biorefinery research in Ireland. Just a quick mention about our group. So our group is the CertBio Research Group at Munster Technological University. We're also a partner and coordinate the BBioNets project through my colleague Carmen Dominguez. And we're involved in a lot of research and demonstration activities related to circular bioeconomy at the national and EU level, as well as educational activities. So one core area of research within our group is around grasslands and green biorefineries. For Ireland, grass is a key resource. It makes up over nearly 60% of our total land area and 90% of our total agricultural land. So it's a a really large, largest land-based resource, really. But I think for a lot of European countries, this would represent also a key resource, with a lot of European countries having over 20% of their total land area in the form of grassland. I've called this a key resource in challenging times. I suppose it's a challenging time for the livestock sector, which is the main sector that's based around grassland. A lot of sectors across Europe are under pressure to decarbonize and become more sustainable, and the agriculture sector is no exception. A lot of countries are placing targets on agricultural emissions, including in Ireland. And we have big challenges facing the farming sector, so we need to understand and try to develop some sustainable solutions. I bring up a couple of other points related to agriculture and some of the challenges that link in also to the potential for green biorefineries. Europe imports around 17 million tons of protein every year. In Ireland, it's around 3 million tons in the form of concentrates to support our livestock sector. There's currently discussions around development of an EU protein strategy to make Europe more resilient, and using our grassland more sustainably and in a more resource efficient way can potentially be a big solution to trying to address this sustainable protein strategy. Also, when we think of the bioeconomy, we think of creating value and diversifying. And I suppose if we look at our agriculture sectors in Ireland, we've seen agriculture inputs rise by nearly 75%. And this is the case again in the last few weeks with the conflict happening in Iran, where fertilizers are increasing, energy is increasing, so it's placing a big pressure. So being able to use resources that we have, indigenous resources, more sustainably to create energy, create fertilizers, create proteins, create more resilience around our primary sectors, but also create diversification opportunities for these sectors as well to enter new markets is a key opportunity as well. So I've called this grass being Europe's untapped protein opportunity. And of course, you know, grass is currently used as a key source of protein for our ruminant sectors, for example, but it's still relatively underutilized in terms of the potential that it actually holds. If you look at the schematic on the right-hand side, and particularly the diagram in grey, which focuses on the different concentrates and feeds that are used in Europe, and there's a lot of them there which are in kind of a light grey colour, which indicates that these are produced in the EU, but soybean in particular is one which we are very import dependent upon, and we have about only 3% self-sufficiency of soy in Europe. So that's a key challenge, and it's a very good protein source from a nutritional point of view from an animal perspective, and that's why a lot of the agriculture sectors like this so much. But it's also has a lot of key sustainability impacts which are quite negative, including transport, deforestation, land use, and a lot of other impacts as well. If you look at the bottom diagram, you can see that soy is, again, it's around 35% protein, but the yield of dry matter tons per hectare is quite low at around 2 tons of dry matter per hectare, yielding around 700 kilograms per hectare of protein. Whereas if we look at our clover grass at the bottom, you yield actually a lot more on a per hectare basis. And even though the protein concentration is a little bit lower, you actually have the potential on a protein kilograms per hectare basis to produce actually a lot more protein from our grassland. And of course, our grasslands are around us in Europe. We don't have to import. We can actually use our grasslands, but the challenge is around getting that protein out and making it available. So green biorefineries, which is the top right-hand diagram, are a process in which we can actually extract some of the proteins from grass and basically press the grass to extract out a juice. And from that juice, we can produce a protein concentrate, which can be made available for monogastric animals who wouldn't usually be able to access grass proteins. And we can keep some of the protein in a fiber-bound form, which is available for cows and ruminants as a replacement for silage. So we're helping to optimize the protein use in grass, making some available for monogastric, some available for ruminants. And you have a residual stream that's coming off the process called the brown juice, which can be used to produce bioenergy. So Jakobos mentioned these operational groups, and we actually tested the model of Green Biorefinery within an EIP Agri operational group in a project called Biorefinery Gloss, which was developing a mobile grass biorefinery, which was transported to different farms with a number of partners. We worked with dairy farmers, for example, as well as pig farmers to test the products we could produce in a mobile grass biorefinery, and to produce that with the farmers on their farms and then test the products in different animal trials and other applications as well. So this just presents the kind of flow of what we were looking at. So we were producing our press cake, ensiling our press cake and testing it as a ruminant feed. We were pressing out our juice, producing a protein concentrate, which was being tested as a monogastric feed, particularly for pigs. And then we had a residual whey or brown juice coming off the process. And this can go to fertilizer or bioenergy, but similarly, we can extract higher value materials. In our case, we were looking at the extraction of fructooligosaccharides, which is a potentially prebiotic product that comes out of the process as well. And sorry, now these are some of the pictures you can see of the different products. So our pressed juice and cake, the initial products. And then from our juice, we're getting these three different products: our protein in the middle, our FOS, our fructooligosaccharides sugars, and then our brown juice, which was tested as bioenergy. So just to talk about some of the trials that we've had. So we initially tested our biorefinery pulp or press cake as a cattle feed. We have done two trials to date, and what we've found so far is that the biorefinery pulp has successfully replaced grass silage in dairy cow diets without negatively impacting on yield. So in the first trial we ran, we did two trials. The first trial we found a comparable performance compared with silage, and in the second trial we actually found that we had an increase in grass in milk yield and also milk solids in the case of the cows that were fed with our press cake. So even though the overall protein that's contained in our press cake is lower because we're pressing some of the protein out in the juice fraction, it's more available, and the nitrogen that's used is used more efficiently, converting into milk, and we're losing less of the nitrogen in the feces and urine. So there's an environmental benefit coming from this as well. So higher nitrogen use efficiency, lower losses of nitrogen and phosphorus in the excrement. And the methane results are mixed to date. So we don't have a conclusion because we've had conflicting results on the methane side. So we still need to do some more work there. The protein concentrate that we extract out from the juice, then we've been testing this as a pig feed, and the extracted, we call it LPC, leaf protein concentrate, has delivered a high protein concentration, which is comparable with soybean meal. So you can see in the case of soybean meal, it's typically around 44 to 48%. Our grass protein concentrate was around 43%, which is a little bit lower. And in some of the trials we've seen internationally, it's possible to go higher than this. So we can have something that's even higher than soybean meal in terms of protein concentration. And that's all depends on feedstock and process conditions as well. So we tried this in two different trials. First of all, at a nearly 30% inclusion rate. And what we're looking at here is replacing out soybean, which is the main source of protein in the pig diet, particularly looking at weaner pigs. And we replaced out 27% of the soybean, directly replacing this with our grass protein concentrate. And in our second trial, we replaced 50% of the soybean. So we haven't gone to 100%, but we have gone and increased the replacement rate through the two different trials. And again, we found very good results in terms of weight gain. In the case of pigs, intake is higher in the case of our treatment or grass protein compared with our control, which is interesting given that it's a new feed that we're introducing into the diet. Similar feed conversion efficiency and overall a slightly higher average daily gain. And this is a result we've seen in the two trials that we've done to date. In future, there's a big opportunity to also isolate human food grade protein, which would be, again, a higher value application from this as well. Just to talk about the use of the biorefinery side stream, so the brown juice or the whey coming from a process to create a circular process. So we looked at the liquid and solid residues of the biorefinery, and these show a high biomethane potential on a DM basis. In the case of the liquid, it's quite high liquid, so it's quite low on fresh weight basis, but high on a DM basis. This can be used to meet the heat and electricity requirements of the biorefinery, because we do have requirements on the pressing side, on the drying side as well, which is going to be needed to be met. So trying to do this in a circular way by using our residual streams as an energy source is important. We've also done some life cycle assessment work. So this is where we're looking at the overall impacts of the process from an environmental perspective. And we carried out a study last year which compared a number of different scenarios of feedstocks in this kind of green biorefinery model around protein production. And we found that we can potentially have a very large, up to and even over 5 times lower carbon footprint when we compare the footprint of our grass protein with imported soybean meal. So there's a potentially big environmental benefit that we can gain from the model as well. Going forward, and some of our work to date has been looking at the high potential for cascading extraction of high-value grass-based products. And these types of products, I think, are going to be important in terms of making this more commercially attractive for end users. So if we can target some higher value materials from this, it can bring a lot economically and can also enter new markets and provide a lot of potential health benefits, nutritional benefits, and other applications as well. So one of the things we were looking at was extracting this FOS sugar, fructooligosaccharides sugar concentrate. So we produced about 10 grams of FOS sugar concentrate per liter of brown juice or whey that we have from our process, and we have a lot of whey in our process. So in grass you have a huge amount of water, so a lot of that ends up in the residue stream of the process, but you have these really nice sugars that are contained in your liquid stream. And we extracted and concentrated this FOS sugars, and we tested it as a prebiotic. So prebiotic are the food source that promote the development of probiotic bacteria, so healthy gut bacteria. And so we compared these grass-based FOS with commercial FOS that are currently on the market. So that would include a commercial FOS source as well as inulin, which would often be seen as the gold standard for prebiotics. And overall, we found very good performance in terms of our grass-based FOS being comparable in terms of promotion of healthy gut bacteria against these different standard products that are on the market. So that was using our lab-based cell culture techniques. We're also currently doing work looking at other different types of products. We have a project called Green Biorefineries, which is working to develop functional rubisco protein or white protein, which could be used as a potential ingredient into the food market and food products from grasses and legumes. So again, this would be diversifying some of our protein. So you'd have some protein going back to cows, you'd have some protein going to monogastrics, and you'd have some protein potentially going to humans, which again would increase the value from the process as well. So that's a key area that's under development at the moment. Also, we're working on the development of processes to target additional ingredients like volatile fatty acids and bio-based packaging materials. So at the bottom right, you can see some prototype packaging materials that we've been working on, which are based on grass fibers. One of the other areas we've been working on is just looking at all kinds of different feedstocks. So we predominantly historically have worked off perennial ryegrass in Ireland, but there's been more of a push now to try and include more legumes, more clover into our grasslands to try and fix atmospheric nitrogen. So a lot of sustainability benefits associated with clover, a lot of benefits associated with multi-species grassland where you can improve soil biodiversity. So we've been starting to look at these different types of feedstocks at bench scale and also alternative feedstocks, so things like duckweed and beet leaves and cover crops. And part of that is to try and make our feedstock supply chain more sustainable, but part of it is also so that we can actually try to produce all the year round, because with grass, you're typically cultivating grass, it's growing 6 to 8 months per year, but it leaves you with a period of time during the year when you don't have grass available. So we've been looking at all these kind of different feedstocks with the aim of making our input supply chain more sustainable, but also longer over the course of the year. And part of that, the next stage of this will actually be scaling up some of these feedstocks. So we've been doing it at bench scale, and we'll be scaling it up to pilot scale at the next stage. I just want to touch on, we have a lot of different projects, so I'm just going to touch on one of them at the moment. So one of our projects is funded by the Circular Bio-based Europe joint undertaking, and it's a demonstration project which is working to scale up a demonstration scale decentralized green biorefinery value chain. And we have 3 different demo sites which are part of this, but one of them is a greenfield site that we're actually developing in Ireland as part of our Farm Zero C project. So Farm Zero C is working to try and develop a climate neutral dairy model, integrating all sustainable technologies related to dairy production, from grassland management to fertilizers to rumen, methane additives and renewable energy and all kinds of different things. So we're working to develop and build this demonstration platform in this kind of farm setting that we can actually test this on a commercial farm. It's a demonstration facility, so it's still at the research level, but we're testing it at quite a large scale. And so within the Rural Biorefineries project, we've been looking at these kind of different feedstocks that we can actually work with in terms of processing it for Green Biorefinery, for protein extraction and the development of other products. We're also working in collaboration with our partners at Aarhus University in Denmark to try and understand the possibilities of developing a decentralized supply chain. So is there a possibility, for example, to do instead of a fully centralized process where you'd ship the grass centrally or transport grass centrally, to do some of the pressing on the farm, so that pressed cake, for example, or fiber can stay on the farm for cows, and then we can transport the juices centrally to actually process them and improve the logistics, and also keep some of that material back on the farm as well. So this is something we're investigating. And then we're doing a lot of work on the value-added products that we can actually get from this. So again, you're looking at pulp going towards cattle feed, but we're testing it again to look at the packaging, food packaging applications. In the case of our protein, we're looking at some of this going towards monogastrics, and we'll be doing some feed trials as part of our work. But a fraction of this could be taken out and made available for human food products, and that's something we're trying to investigate, that we could co-produce what we call green protein concentrate along with the white protein concentrate for 2 different applications. Our brown juice then we're testing as a bioenergy source as previously, but we're also working on developing a 2-stage anaerobic digestion process, which would produce volatile fatty acids and extract those fatty acids and test them in applications like flavors, antimicrobials, and a variety of different applications. And then some of that after those are extracted, we're still producing bioenergy, which would come back into our process. And then all of this has been done in collaboration with research partners, but also industry partners. So we work with a pig co-op in the development of this trial, which will be testing our green protein as a source of nutrition for pigs. We're working with Carberry, a very big agri-food dairy food producer, to test these white proteins that are coming from grass in prototype food products. So there's a big industry element to this as well. This is just some kind of pictures of our piloting facilities. So this was funded from national funding through Enterprise Ireland, but then we're using it within our EU projects, for example. So this is where we can test lots of different feedstocks to understand their potential for scale up towards our larger demonstration scale facility. And this is just a couple of slides on our demonstration facility, which is funded by the Department of Agriculture, Food and the Marine in Ireland. And again, it's a collaboration between Carberry, the dairy producer, and then MTU, where I'm based, and University College Dublin. And this is the kind of mock-ups, and the site is currently under development. So it's quite a large facility. We're aiming to process approximately 10 tons of fresh weight biomass per day. It's a PLC controlled system, so it's quite an integrated, automated process. So it takes some of the labor out. There's still some labor required, but it reduces the labor requirements. We have flexible pre-treatment options. We'll be producing our different products, some of which will be processed on site, and then some of which we'll be working with our collaborators downstream to develop these further into high value products, as well as some products which can stay on the farm as well. This is the facility under development. This is various stages of development. So we are hoping to put the plant into operation during the summertime. And these are just some of our projects. So we have a number of projects working on this as well. Just a final slide maybe on the lessons we've learned going all the way from the biorefinery gloss EIP Agri to the work we're doing now to actually scale that further at Farms ARC. So I think based on our research, Green Biorefineries can be a great potential model for unlocking potential of rural areas, and grass is very abundant. So it's a big potential to balance current use of grass, but also open the door to new applications. And I think it's a very scalable model. The model aligns well with many of the key EU challenges like emissions and proteins, and trying to create future-proofing farming, development of high-value materials, making farming more competitive. It also brings key sustainability and resilience benefits, but couples with high-value ingredients. That's going to be an important part of its success as well. I think it's important to develop a robust process with flexible feedstocks. So will improve it and allow it to be more competitive across the year. I think this is really important, the partnerships with primary producers and industry, which we've had to date, and we've been working with the farmers that we've worked with for the last 10 years really on this, going all the way from the biorefinery gloss project to the current projects like Rural Biorefineries, working with the same pig farmers, and Carberry as our dairy co-op, and a number of other partners. So that's really important to make sure that the research is relevant, because you're getting feedback from relevant stakeholders involved in this. But it's also been really important in terms of increasing visibility and impact, so that a lot of farmers are very interested in seeing things in practice, not maybe in the lab, but actually out in the field. So being able to interact with farmers in a kind of farm setting, and so that farmers can learn from researchers, but researchers can learn from farmers, and farmers can learn from other farmers, it makes it much more possible. And then just to say, there is further work needed to develop policy and market to help with let's say, the commercialization of some of these technologies as well. So thanks for your attention, and I'm happy to take any questions that you have.
Thank you very much, James. It was really impressive, and the work you are doing there. Just for you to know, there is a question from Peter in the chat, a very practical one. But if we can proceed with the next speaker, and then we can start with this during the panel session. Is that okay with
That's fine.
you?
Yeah. Thank you.
Peter, okay? Okay. Well, Magda, your turn. Unmute yourself. Okay.
Okay, now I'm unmuted.
Yes.
Do you see my presentation?
Now, yes.
Perfect. So my name is Magdalena Bożencka. I'm representing Institute of Soil Science and Plant Cultivation. I did this work and preparation for the work with my colleague Piotr Gorzkowski, who is GIS expert, and he was supporting me on this work. I will tell you a little bit about Polish case and technical potential of biomass, but I would like to start with some of the things that were said already, but to add something to it. The total area of permanent grassland in the European Union is about 50 million total, and average utilized area is 31%. The largest producers of permanent grasslands are France, Spain, Germany, and Russia. As James said, Ireland is the largest owner of utilized area for the permanent grasses. In the recent years, the change of permanent grasslands among European countries have changed by on average 3%. The highest growth was noticed in Spain by 27%, Greece, Portugal, and France, which are the Mediterranean countries. There is a good environment then for the changing the area to permanent grasslands. Unfortunately, in the Baltic Sea, due to the changes in our recent years with the intensification of production, reducing the amount of feedstock, we in Estonia, Lithuania, Poland, we see the decline even by 33% in Lithuania. When we think about feed demand and energy supply from permanent grasslands, we have to first think about the primary use, like livestock feed, and the fiber from ruminant livestock, hay, silage. All those things have to be fully satisfied before we think of using it for renewable energy. And in this case, we can think about biomass and bioethane production, pellets and biosolid, and also different kinds of dual fraction conversion processes. There are also several barriers that we have to overcome when we think environmental and we think about the intervention and commitments. I will show you some things later on about it. Those constraints cuts biogas yield up to 5%, up to 5 times. This is due to the late cutting of the grass. There is a lot of logistical, low bulk density of hay, high transportation costs, very seasonal availability of the feedstock, storage losses up to 30%, which are quite high. There are still technological barriers that have to be overcome. And very important regulatory and economics, some constraints from CAP, uncertainty on market prices, high capital cost for biogas infrastructure. Many of these barriers can be kind of trade-off by environmental benefits like carbon sequestration, biodiversity support, soil erosion prevention, which is quite high when we think about grasslands, a lower life cycle, greenhouses, gas emissions versus energy crops. There are some logistical benefits. There is no need to land use change. There is existing farm infrastructure that does not need to be changed. It can be integrated as well with livestock management calendar. Some technological benefits, those dual fraction processes enables both solid fuel and biogas from one feedstock. There is this mature hay baling supply chain, which already exists. Regulatory and economics benefits are like eligible for CAP eco-schemes payments, fits EU biomethane targets, and also it can support rural employment creation. When we think about Poland, permanent grassland in Poland are around 3 million hectares. As an institute, we are quite lucky when we want to calculate the biomass potential from these crops. We have the data from Agency for Restructuring and Modernization of Agriculture. They collect the data from farmers, and we are allowed to use this information. So when we start, we select our fields with the permanent grass. We also try to calculate the potential yield from 3 grass cuts, and then we again, as an institute, are quite lucky because we have a large database of weather conditions in Poland, and based on that, we estimate drought impact based on climatic water balance. And when we reduce this first theoretical yield by the drought, we can also include application of agri-environmental climatic conditions and incentives. So we know, I will show you in the next slide how we do it. And then afterwards, we also have the amount of animals living in Poland and locations of those animals. So we can aggregate and come out with hay surplus that is available in Poland. So those are the requirements for agri-environmental climatic interventions. So there is several variants that farmer can use to get extra subsidies, but those variants, they require different mowing frequencies, left unmown area, and also they set up the mowing dates when the mowing should be done. And as you see, many of those variants allows you to cut the grass, for example, in September. So this make the yield lower, for example. After all the calculation, we comes out with the maps of theoretical and technical potential at the municipality level. Due to RODO rules, we are not allowed to show it by the field, but at municipal level, we have those information, and further on, if we need to make some local assessments, we can go closer. So when we look at the theoretical hay potential in Poland in 2024, it was around 15 million tons. But when we start to include those droughts, when we include the amount of animal, the technical potential in Poland goes down to minus. But if we think not the whole Poland, but the municipalities, then we see that in some areas there is quite a lot of hay being left that potentially it could be used for energy production. Because we have this data for last several years, we can also see ongoing regionalization and monitor how and why these changes are being done. Mostly it's based on the subsidies that farmers are receiving, and also it is based on the amount of animals living in this area. So those information can be very much value for allocation of future biogas plants, and we do also very similar calculation for other crops in Poland, like straw, for like corn, where we see the straw biomass, and it supports the plans for setting up different energy uses. A part of monitoring for Poland in past, we have done a similar model for the whole Europe. It was not as detailed as Polish one, but we did analyze straw, residues of pruning, livestock residues, forestry, green urban areas, perennial crops, roadside vegetation, biodegradable municipal waste, and bio-waste of food industry. We have developed different methodologies for those different sources of biomass, and it can be found on our BioBoost Geo portal. We also can see, for example, when we talk about hay from permanent grasslands, we can evaluate the feed priority and energy surplus in several countries. When we go deeper into, when we want to look into grass potential in European Union, is quite similar situation like it was in Poland. The theoretical potential is quite high, but when we include animals and drought monitoring system, then the potential goes down. But you must notice that this is NUTS 3, which is quite large area. If we were able to have a data in smaller regions like municipalities, it probably would look completely different. But this is a kind of basis where we can start analysis for either other countries or people who, or investors who will need this kind of. So to summarize, the feed demand is binding constraints. Livestock hay consumption firstly must be fully subtracted before any other biomass can count and be used for energy resources. Treating theoretical potential as available, it's a big overestimating measure. Agri-environment climate interventions reduce biogas up to 5 times. So this is very important. It was proved in the publication of Prochnov 2009. Surplus zones are geographically concentrated, and many of countries show significant surplus, but unfortunately, well, or fortunately, when we include the animals, it comes out that there is no biomass to be used for energy. And very important, NUTS 3 aggregates height intra-regional heterogeneity. So municipal analysis should be taken, and they will show the possibility of using and surplus of biomass. Thank you very much for your attention. If there will be any questions, I'm happy to share, to answer them during the discussion. Thank you.
Thank you very much, Magda. Impressive work combining agriculture and GIS technology, so the mapping stuff. Perfect. Now, Andrei, it's your turn. Switch on your mic, share your screen.
Thank you. I just shared the presentation.
Okay. Put it in presentation mode and proceed.
Okay, just a second.
You want me to share?
If you are able to share my presentation, it will be nice because something went wrong in my computer. And
okay, now. See my screen. Share. Okay, now you should see. Okay. Do you see it?
yes, I am.
Okay.
And the others?
Yes, we can.
Okay,
Yes.
perfect. So sorry for the technical issues at the beginning. Once again, good morning, ladies and gentlemen. I bring to you some experiences from the industry sector, from the construction and operation of biomethane stations. Can we go to next slide, please? Thank you. I'm 18 years in the biogas sector. Started as a designer of biogas plants, then the chief sales officer, and also I'm operating one plant, which is biogas and also biomethane plant. I will talk about this project later. Can go further. Our company Agricom or Agricom Bohemia is a Czech company, but we belong to the European Agricom company. We are turnkey suppliers of biogas and biomethane technologies and service organization. And we have our design department, laboratory, and service. Next slide, please. Here are our references within whole, mainly in Europe. We construct more than 1,000 biogas plants and nowadays almost 60 biomethane plants. On the next slide, you will see references of Czech Agricom Bohemia, where we have roughly 100 realizations, from which 87 are biogas plants. And in Czech Republic, we have roughly 530, 540 projects right now. So we are the biggest supplier and producer with about around 15-17% of the market. On the next slide are our activities in Slovakia. The total amount of the plants in Slovakia is about 100. So Czech Republic 500, Slovakia 100 only, and we built there 7 projects. Here I borrowed 3 slides from EBA, European Biogas Association, where you see the nowadays tendency in our sector, because the biogas sector traditionally producing electricity and heat slowly turns to a gas sector. On the graph, you see the increasing amount of biomethane production, which is now to 5.2 billion cubic meters in Europe, and is increasing every year. and the increase is 7 billion cubic meters per year. So it slowly increase. On the next slide, you will see the localities where the biomethane boom already started. It's France, Germany, Italy, UK, Denmark, etc. It means the Western and Central Europe. In other countries, they are still waiting for the boom. Regarding the technology, the majority covers membrane separation technology. It's the technology which is convenient for the smaller plants, which are usual in those countries. Smaller plants, I mean the plants which can produce in electricity roughly 1 megawatt, maximum 2 megawatt of electricity. For large-scale project are better at the other technologies like chemical absorption, water scrubbing, or pressure swing absorption. Next slide, please. Biomethane and biogas sector, it's not only the production of electricity, heat, and gas in mean energy, but also is connected to production of very important fertilizer, which has very high fertilizing value. Every material which goes through the plant ends on the field as a fertilizer and contribute to a big GHG reductions. Now, why to use the biomethane? It has ecological benefit, and because of reduction of greenhouse emissions. For the farmer, because the majority of biogas plants are farm-based plants, is it a stable, predictable source of income? And because the biomethane is more sensitive to energy crops or to raw materials, it's also efficient with utilization of waste. When we compare the production of electricity and production of biomethane, in the electricity, you don't care too much about the raw materials from which you create the energy. In the biomethane, is the situation different, because when you sell the biomethane, even on the market or with some operational subsidy covered by state, you always consider the CO, the GI score, the CO2 footprint. We can divide the inputs into 3 basic categories: corn-based materials, waste materials, and manure-based materials. And if you, from all 3 categories, you can make the same biomethane, but these 3 categories have different GHG score. And biomethane from the manure is nowadays the most valuable. It has the biggest carbon savings and can be sold on the market for the best price. And that's why the biomethane plants are focusing on the utilization of more on the waste or manure than on the corn materials. The differences are quite significant. If I summarize sum the price of the molecules and of the green certificates together, for biomethane made from corn, you can get roughly 60-80 euros per megawatt hour. For the biomethane based on waste materials, you can get about 100-110 euro from 1 megawatt of energy in the gas. and from the biomethane made from manure. This can be sold on the market for 2027, let's say, for 150, 160 euro. So for the biomethane is very important, the raw material from which we create because of selling the green premiums. And of course, it's a great substitution for fossil fuels. Next slide, please. Here is the overview of Czech Republic, Czech situation. Our market is very, very young. It's a small baby right now because we have 500 or almost 600 biogas plants, but only 13 biomethane plants. Majority of biogas plants are agricultural. They are producing the electricity with some operational subsidy, which will be ending within between 2028 and 2033 right now. And we hope that a lot of projects will be turned to biomethane in the future. We have a target, quite challenging target, to have 500 million cubic meters by 2030. But now we can produce only roughly 20 million of cubic meters nowadays. On the next slide, you see two basic paths for existing biogas plants. One path in Czech Republic is modernization, which means that you still be continuing in the electricity production. Our government has built a new operational subsidy scheme for electricity production, but unfortunately it's not very convenient right now. The subsidy scheme calculates with high utilization of heat, which is from the technical point of view obvious and smart solution, but from the practical point of view it's very difficult to achieve utilization of high amount of heat. The other way how to prolong the lifetime of the existing plant is repowering or transforming to a biomethane plant, where you can use also the operational subsidy. Right now in Czech Republic, we are at the beginning. Ministry of Industry promised us that till the end of this month, they will announce a first auction for the OPEX subsidy. So we are waiting for, let's say, boom of new projects. And we hope that this subsidy will be very convenient and we will speed up the repowering of existing plants. Those plants which are existing right now in Czech Republic are mainly based on a market. On a market, they sell the biomethane principally to Germany, Denmark, or UK. Yes, this I already said the coming auction, so we can proceed. And this I comment also. So next slide, please. From these 600 stations, we estimate that 200, maybe 250 can go to biomethane, and I think 100, 150 can continue with a high utilization of heat and continue to electric production. But still there is a quite big amount of plants which unfortunately will be closed in Czech Republic. This phenomenon is very bad. It's not convenient because we feel that it's a pity to close existing plan which is operating for 15 or 20 years, and there is no need to do any strong technical changing. But the situation is like that the green energy can be made more cheap from non-fuel sources like PV or wind energy. So the future of the biogas is like this, that definitely some of the plants will be closed, and the future is, according to my opinion, only for the plants which can be turned to biomethane plants. The increase of biomethane plants is always connected with the connectivity to the gas distribution network. So in our country, we have one big network, but on the different pressure levels. All the existing projects are connected to high pressure network, and because there is enough capacity and no problem of connections. In Czech Republic, we have also wide network of middle pressure networks, where are a lot of plants in very close distance to this network, but unfortunately in this network is not enough capacity to connect the power plants. So we hope that new projects will come which can adjust the network and combat and build up a new compressors which will be able to pump the gas from a middle pressure network to the high pressure network, like reverse flow compressors. This is just a demonstration of our technology. It's a membrane, a container with the membrane separation technology, three phases membrane separation, which works like molecular sieve. We are sieving the molecules in coarse way, in fine way, and in last step we are sieving the last residual methane molecules from the CO2 molecules. From this device goes on in one tube of pure methane to the distribution network. From the second stream almost pure CO2. This CO2 can be blown in the air or utilized. I think it will be on the other slides. Okay, we can skip this, just technical data. Yes, so CO2 utilization will be later, I'm sorry. First, I will mention the two projects which we have in Czech Republic. This project is my plant, where we change the production from electricity to biomethane after 10 years of operation. Now we are producing biomethane 100% from manure with very significant CO2 reduction emissions. And this modernization or repowering was done during the operation. It was very difficult thing. We had to do a lot of changes in the technology. One significant change is that we need to change the desulfurizing technology in the existing plant, where we originally injected air for reduction of gaseous sulfur to solid sulfur salts. In the air is a high amount of nitrogen, roughly 80%, and this nitrogen is very difficult to separate on the molecular sieves from methane molecules. So we changed the technology. Now we inject in the existing digesters pure oxygen for oxygen generators to avoid mixing the gas with the nitrogen gas, and we can easily separate methane molecules from the CO2 molecules. So that's one of the technological change you need to do in the existing biogas plant when you go to biomethane plant. Some pictures from the technology. Technology is under operation since May 24. So soon we will have 2 years of operation. And last year on the St. Valentine's Day, we turned into operation this new plant, Krakořice, which were officially opened on the 19th of May by the representatives from government. We can go further. This plant is pretty new. You see the picture. It was complete new project on a green land. It's a new agricultural biomethane plant based on manure and corn. This plant has a CHP unit and upgrading unit. The biogas for the CHP unit is made from corn, and the biogas from upgrading for biomethane is made from manure. This plant is self-sufficient, so it can produce own electric energy and own heat for heating of digesters. And from my point of view, to have a own energy source, CHP unit in the biogas, in the new biomethane plant is very important, because we see it in operational and in the services that the CHP unit is really important to utilize the gas when the technology of membrane is not able to be operating from for example service reasons. Some remarks from the beginning. The most tricky was to start the biology. We transport hot digestate in the isolated tanks from the other plants which were nearby. The start of fertilizing process took almost 1.5 months. Within this month, we need to heat the system. First, we heated the system with the diesel heater. Then we start the CHP unit and combust the biogas and heat the system with the heat from CHP unit. In the end, when we achieved a really good quality for starting of membrane technology, we started to produce biomethane. This we can go further. It's only a slide about the gas grid operator, and at the end of my presentation, I just want to show the potential of the gas from different raw materials. So there is a quite interesting biogas potential from the waste materials like a food waste, lecithin sludge or G-phase. So here you see that that is good to use these waste materials, but from the economic point of view, in a biomethane sales, it's the most important manure. Okay, here is the technology which we have under operation in France, close to Paris. Is a CO2 liquefaction technology, and it's a perfect add-on to biomethane technology because it utilizes the residual stream of gases, the CO2 which you cannot inject into the gas grid. We can liquidize this CO2, and by this liquefaction we clean it, and we clean it either for industrial quality or food grade quality. For industrial quality, we use it for dry ice production, and in food grade quality, we can use it in beverage industry, for example.
Ondri, sorry to interrupt you, but we are running out of time. Can you please?
Okay, I'm sorry. I think I'm at the end of my presentation. So please, can we go? Oh, yeah, that's it. Yeah. Thank you for attention, and sorry for technical issues and a little bit time more than
no problem. While sharing, I don't see any reactions or anything else, so that's why I was interrupting you. Sorry for that. Now we can proceed with the questions. I mean, any further information we would like from the speakers to share with us. Margorzata, the floor is yours. Sorry, Daphne?
Perhaps before we move on to the panel session, we can take a group photo for reporting and dissemination purposes. So if that's not a problem with you also, I will kindly ask anyone who wants to be included in the photo to open their cameras. If you don't want, please don't open it. And give me a second, please. Don't forget to smile. Thank you very much. Now we can proceed to the panel session.
Now everyone, switch off your cameras and I'm just kidding. Margorzata.
Thank you. Thank you, Jakubos. Thank you, Daphne. And thank you to all of our presenters today for very interesting, informative presentations. You addressed very current topics and very current problems we have with energy generation, with relying more on our potential, local potential, and limiting the reliance on fossil fuels. So we would definitely like to learn more about that. So we encourage everyone from the audience to ask questions either in the chat or raise your hand. And we already have several questions in the chat addressed to James. So let's start with James. I can see you have already answered several of the questions, but maybe you would like to add some detail. The first question from Peter: how do you separate metals and plastics from the grass going into the screw press? Would you like to comment on that?
Yeah, sure. So we're still setting up our pilot. We've got our pilot operational. We still have to operate our demonstration. So some of this will still be part of our research around testing ways in which we can do that. Like some of the pilot plants that exist at the moment use industrial washers, like large-scale salad washers for washing biomass going into the process. I mentioned a kind of innovation around using technology recognition for identifying things like plastics, metals in green biomass, which was developed by Wageningen University for their pilot plant. So basically it stops the process when it recognizes kind of foreign objects that are contained in biomass and screens out the foreign objects. That's being implemented at a pilot scale currently. I think there's also differences in terms of how the grass is managed, which will have an impact on the risk of how likely it will be for those types of materials to be contained in grass. And some of the better managed pasture grass will probably be less likely to have, for example, a lot of plastics or a lot of metals contained in it. So I think it's a bit of both, a bit around understanding where the grass is coming from, but also trying to integrate different technologies. So we haven't, in our work so far, we haven't worked specifically on research around this. We're mainly optimizing our process, and for us that part will come a little bit later, but it's an important part of the process, from any kinds of materials that are there, but can both have an impact on technology and the facility being able to deal with it. For example, metals and stones getting blocking up our press and things like that are going to be a big problem, and then also potentially ending up in products later as well.
Thank you, James. So this is, I guess, this is not a big problem with grass from permanent grasslands, but it's good to know that there is a technology that can remove the plastics and metals from the biomass feedstocks. So, does this answer your question, Peter? Or you would like to follow up on that?
In part, because as Magdalena Borcega has indicated, there is a lot of grass used for feed of cows, and there is another part of the grass that is available is in the landscaping. So roadside grass that is used in Holland, in the Netherlands, is available for pressing or for using, and it doesn't have any opportunity only to make compost out of it. But if you could take out the waste, the debris, the metals, the plastics, then it would be a very interesting source of grass to put in the press.
Yeah, this is true. At the moment, I think most of the projects which are focusing on the roadside grass, like I think you have companies out there. There was a company called New Foss and some other companies who were taking that grass and making materials like packaging materials. So I'm not sure what they're doing in terms of treatment of that grass at the commercial level. But most of those companies tend to have a less of a focus on protein extraction, more of a focus on material production from the roadside grass compared with the pasture grass. But it's still a challenge, and it's even a challenge for us. You mentioned stones. I mean, you're going to find stones on farms as well. So it is something that even on the protein side, we're going to have to consider as well. Sand, other materials, which are going to be, the more of those types of materials, the lower quality that's going to be going into your process also.
Yeah, for both of the processes, when they are using a screw press, and with the sieve, it is blocking with metals and also blocking the screw itself. That is a very difficult part, I think.
Yeah.
It looks easy, but it's not.
Yeah, that's a good point.
Okay, thanks, James.
Thank you, Peter. Thank you, Peter, for your question. So the source of biomass would also determine the product that we can obtain, and the quality. What about the next question from Pia? What are your perspectives on the need for policy and market development? How can we proceed here?
Yeah, my answer to that was that there's lots of areas that are policy barriers for some of these different products. Like you have a very challenging requirements. So any of the high value products, especially where they're going into the food market, there's novel food regulations that are quite challenging in terms of for companies trying to bring these products to the market. It takes quite a long time. It can be costly as well to do this. So this is a challenge, and companies are going to have to face that. So that's a challenge. I think one thing that I think is important is to somehow also change the narrative in terms of grass only being a forage crop for ruminants, and potentially being a protein crop that can be used for potentially other animals, non-ruminant animals, and potentially humans as well. and to change maybe the perspective on how grassland can be used, so that when we talk about novel crops and alternative crops for proteins, that grass becomes part of that conversation. Because I think if that comes into a kind of, let's say from a policy side, if that becomes accepted that grass is going to be a protein crop, it will influence the policy around it as well. So things like supporting, we'd say, cooperatives around alternative protein crops, which already there's a number of programs going on across Europe in many member states around supporting the development of new protein crops and indigenous protein crops. I think it's important that grass is part of that discussion, because then you're going to have supports for example, new cooperatives who want to develop initiatives around this, potentially subsidy schemes. Whereas if grass isn't part of that conversation, it's at a disadvantage compared to some of those other crops. So I think in terms of getting the support of the CAP program and things like this, I think having it at an EU level as a kind of designated protein crop in the form that it's refined to produce these types of protein products, protein concentrates from them, I think that would be a big step in supporting the development of this activity at commercial level.
Thank you. And that would probably also support its transferability across regions, across countries. Would you say this is an easily transferable technology to other countries? What would be the key conditions to do it successfully?
Like I think it's very transferable. It's already at a certain scale in many countries. So we're doing some work. It's already being developed in Sweden, in Denmark, in the Netherlands. So there's already a lot of countries doing this. You have grassland in different forms all across Europe. So the process doesn't really change too much depending on the type of grass, whether it's ryegrass or alfalfa or clover. It's relatively the same process, and it's relatively low complexity, especially at the stage where you're looking at the animal feed, the bioenergy, the forage. When you get into some more of the food crops, that's still a bit of an area under development. But a lot of the projects, we've done a lot of projects working directly with the farmers on this. So it would be relatively low and relatively low complexity, and also something that is likely to be implemented at not the very, very large scale, sort of a medium, let's say a regional approach to this, which might involve a number of farms, I think. So from that point of view, as these types of technologies go, of course it's complex, but it's less complex than a lot of bioeconomy and biorefinery solutions.
Yeah, exactly. Thank you. We also have another question from a bit different point of view. Have you connected social science and political science analysis on the work you're doing, investigating barriers, potentials for the uptake among farmers and the whole value chain from Morten?
Yeah, so that's really important as well. I mean, we've done only a limited amount of analysis on it. What we have done, which I think is important, is that we've done these types of projects directly with farmers. So we've actually had this kind of system where either on the mobile refinery or some of the later work we've been doing, we do work with farmers on the project. So in that sense, you're getting a lot of less informal feedback in terms of the work you're doing. So when you're working with farmers, they'll tell you what they see as the challenges associated with some of the technologies and products and where it fits. On the kind of form analysis side, we have done some kind of focus groups where we've done kind of co-creation activities with farmers and other stakeholders to try and design a model that might fit for them and to do some analysis on this. We haven't done any, or at least we're kind of at the early stages of developing a kind of deeper analysis, which would involve surveys with farmers to look at things like acceptance of this by farmers and rural communities and where that fits within their current, work, whether farmers would accept this in full or in part as part of their activity, whether they'd like to be involved, how they see the products we're producing aligning with what they're doing already. So we don't have probably enough deeper analysis, but it is something we're planning to do, not just in Ireland, but in Denmark and a number of other countries as part of one of the projects we're working on at the moment. There may be other work that's being carried out by other institutions on this, so I'm not 100% sure.
So we're looking forward to learning about your results. I'm not sure if there were any raised hands, so anybody would like to ask a question to James?
Margosota, yes, I see it
Yes.
too. First, Pertti, and then Pia.
Yes, thanks everyone. My name is Pertti Miettonen. I'm from business Christina Stud's living lab called Christina Eco. We're on the western coast of Finland, and we are cooperating with a number of universities and research institutes in circular bioeconomy in our area. And I have a comment and a question. The comment would be when we're discussing about removing the aluminium and metals from the grass biomass, is that we have been working with a similar type of issue with our greenhouse businesses, because there are a number of wires and clips which are made of metal, and those have made it if not impossible, but anyway difficult to valorize the stems from cucumber and tomatoes, etc. So we are now developing a business model rather than technology, where the user of the biomass could provide the greenhouses with biomaterial of the clips or wires made out of biomaterial, and then release this biomass also from greenhouses. So that's something that may bring us some more material together with the grass that is in the area, but sometimes it may be the business model that can make the change rather than the technology. And my question is, maybe we can discuss that later in the panel, or whatever you feel that would fit the agenda. At least James mentioned logistics. And that's also one of the key points that we are investigating at the moment, that how to improve the logistic chains of biomass, because we all know that the biomass is very much scattered and low volume within the area. Maybe using the artificial intelligence to plan the roads together with the logistics companies. So I would very much like to hear if there are some already very good benchmarks in how the biomass logistics have been developed in your areas, or could there be something that we could, for example, take a look together? Thank you.
Thank you very much. I actually know about a project that Magda is involved, which is developing bioplastics, among others, for greenhouse uses. So maybe she would like to comment further on that. But first, let's move on to Pia. Pia, would you like to follow up on your question? I've seen your hand raised. Oh, you are muted. Please try to unmute yourself.
Oh yes, I actually would, but I'm sorry, I have to leave. I was just about to post in the chat, but very interesting presentations. Thank you. Thank you very much.
Thank you, James. We need to speed up a bit, so if there are any further questions, we encourage you to type them in the chat. And maybe now let's move on to Magda. Magda, would you like to comment on what was already said about the use of bioplastics and removal of them from the biomass sources?
Well, we all know that this is a very big problem, maybe not even with the removing of metal, but normal plastic that we use in greenhouses. So that's why we are in a consortium of Soul project that develops 11 different types of bioplastic material that can be used on farms, and it can replace clips, foils, stamps, and many others. So if anybody would be interested in learning more, type Soul in the internet, and you can find what we are doing.
Yes, so we of course encourage you to continue this discussion, and maybe in the chat or exchange contact details. We will have time for that at the end of our discussion. And now I would like to ask Magda a question regarding her presentation, because Magda, you presented the assessment of technical potential of permanent grassland biomass in Poland. What would you say are the main practical barriers that currently can limit its wider use for energy production, if any?
Well, of course, those barriers that were mentioned for the whole Europe, they all apply to Poland. This is very important to understand that the theoretical potential is really high. The technical potential is quite low. But in meantime, we have to focus on the regions, because as you could see in Poland, there are some points that there is a lot of biomass, and this biomass is available. The same situation is within the whole Europe, and deeper analyses are needed, and they can support all those environmental, logistical, technological barriers are in a way under development, and they kind of, we are looking for ways how to overcome them. Regulatory and economists, it's something that needs to be done by our government, and this is something that they work on as well. But in many of us' opinion, this work should speed up. There is a lot of regulatory issues, uncertainty in energy market. Farmers need a lot of capital to invest, and they need a guarantee for future work, longer contracts, and kind of capital to invest, for example, in biogas production, or support to, for example, implement the devices that James was presenting, and building the value chain and possibilities of expanding this market.
Thank you, Magda. So also some policy support would be in place here. Would you say this methodology you used to estimate the technical potential of biomass could be easily transferred to other EU countries, or would it require some adaptation?
Well, it will all depends on the data that is available in the country. We did try, as I showed, to do similar models for the whole Europe, but the data available right now, it's in a NUTS2 level, so it's really big regions, and it does not represent the real potential of the country. We could analyze the kind of hotspots, being in contact with the authorities, with universities in this region, collecting all the data necessary for smaller areas, and then proceed with analysis. And not only the permanent grasslands, but also biomass resources from other, because grass is growing also for at the side road that we've heard just before, and include all those availability, and then moving forward with the analysis.
Thank you. Thank you very much for answering this question. I cannot see any further questions in the chat, so I would like to, because we need to speed up a bit, yeah. I would like to move on to Andre. And Andre, if you could tell us more about, well, considering the planned introduction of biomethane support actions, this expected modernization of existing biogas plants, infrastructure constraints that you've discussed. How do you think, how would you say this Czech biogas, biomethane sector will evolve in the next decade, let's say by 2030?
Okay, so the operational subsidy is designed for new projects from 2027 up to 2030. And the government expects 500 million cubic meters, as I mentioned. We feel that this goal is very ambitious, and I expect that in a very optimistic way, it will be half of this capacity only. And what can help will be definitely the solving of technical issues in the gas distribution, because a lot of projects has problems with connectivity to the gas grid network. I mean to the high pressure gas grid where is a capacity. So after the solving of these technical issues, from injecting the gas from the middle pressure to the high pressure with the reverse flow compressions, the goal of the Czech Republic and the biomethane can be achieved much more easily.
Okay, thank you. So you already know that this will be a challenge to reach the targets. How would you say, is this based on your experience in Czech Republic, is this technology easily transferable to other EU countries? I've seen on the map you presented there are already numerous biogas, biomethane stations in west of Europe. What about the east of Europe?
Yes, definitely. It's nothing new. The technology comes from the purification of salt water. If you were on a boat somewhere in the Mediterranean, this is the technology which creates you potable water from the seawater. So it's very well-known technology which is adaptable to every market. In Slovak, there is already 3 plants, biomethane plants under operation with the membrane technology. 4 other in Slovak are under construction. So Slovaks will have soon 6 or 7 plants. In Czech Republic, there will be soon number 14. And our company is also active on the Polish market, and we are constructing biogas plant Śniadowo. And in Śniadowo will be a second plant connected to the gas grid. So even in the Poland, there is very slowly starting a new era of biomethane. So it's totally unproblematic to use it on the other markets. It's only about the local policy, because green energy cannot be done without the incentives, unfortunately.
So I was going to ask about that. So you say you already stationed in Poland, and there are two successfully implemented stations in Poland. Yeah. Okay. Thank you very much. Are there any other questions to Andre? We are a bit past our schedule. Not in the chat. No raised hands. Thank you very much. Thank you very much to our speakers. Thank you very much to the audience, to your valuable input in our discussion. And now I would like to give back the floor to Jakobos.
Thank you very much. I have only two things to share with everyone. It's the the information that we created during the project implementation, it can be found in our website. We created a platform where you can browse and see the results and the training material. Just to let you know that all the information from all cross-fertilization meetings is already available in our website. The last one obviously will be in 1 or 2 weeks. And we are organizing an event next month in Brussels, which you can also attend online. It's about policy discussions around the creation and implementation of operational groups, and 2 are the main topics. And the second one is about business models, and especially in line with the new bioeconomy strategy. Well, feel free to check it. We'll share the link to the agenda and the registration of the event in the next couple of days. And we'll hope to see you or hear from you again, either within these meetings, or we'll be in touch via email. So from my side, thank you very much, everyone, for your time and effort, and we'll keep on via emails. Okay. Bye, everyone.
Thank you. Bye.
Bye. Thank you.
Bye.